Okay, guys, let's review box plot and 5-number summary. Okay, let's go ahead and get into Desmos. So remember, it's under resources and we open it in the sidebar. So let me move it, resize it. And I will type L equals for list. And let's click on the data button and let's get the data into Desmos. Okay, so just copy paste it, Control C, Control V. Next is the 5-number summary. So super easy because the command is stats L, and that just gives you the 5-number summary. Let's put commas between numbers and remember to put them in correct order from left to right. Now, this other box will ask you to indicate what are the correct units. And usually they tell you that in the question. So if you read the question, you can see that it says in minutes. And so that will be what we would want to choose. All statistical measures that we consider have the same units as the original data, which is minutes. All right, how do we find the interquartile range? Well, that is just the difference between the third and the first quartile. So let's subtract them. Remember, interquartile range is always a positive number, so that would be 17. And the lower fence and upper fence formulas will be provided on the test. You do not need to write them down. You're just going to compute them. So Q1 is 13 minus 1.5. And then multiply. You can use the multiply from the keypad or, well, where is it? It's right here. Or you can use the asterisk, which is Shift 8 of your keyboard. And then type your IQR. Now, don't be afraid of like the lower fence being negative, even though my data is positive. That can happen, and that's just because you're subtracting. Okay, so that means likely that you're not going to have any outliers on the left side because this data is all positive. And you're not going to have any numbers that are smaller than the lower fence. And then let's get the upper fence. So that would be Q3, so that's 30 plus 1.5 multiplied by IQR. So that would be 55.5. All right, so if you just have that's all you got, and you want to know, okay, do I have any numbers that are outside of this range? So all you got to do is just type sort L. That gives you the sorted list. And you ask yourself, okay, do I see anything below negative 12.5? Well, no, we already talked about that. But do I see anything higher than 55.5? Well, yes, that would be 59. So that's my outlier. Now, I would also double check that with the box plot because it's always going to give you the right answer. Even if you messed up with the fences or didn't know how to do it, you have no excuse because box plot will do it for you. So box plot command and then L. And then what you for sure have to do is zoom fit. So go back over here, click on this, that's zoom fits, so you can see the box. And also go to the hide expression list to get rid of the left-hand side so you can see the plot better. And I do see an outlier right here. So if you get closer, you can see right here. That's a dot that's separate from the box. When you click on that dot, it'll tell you what the outlier is. Just make sure to ignore the y coordinate because that just tells you, like, how high that point is, but that's not what you want. So you want this number right here. That's your outlier. That's 59. And we already know that, but we just confirm that through the use of box plot. Okay, now what do we use to answer questions E and F? Well, I'm going to tell you that in a second, but I actually want to match the box plot first. So my box plot has to, first of all, match the 5-number summary, except because of an outlier, we might not see them, like the minimum will be the same, but the maximum will not be 59. Like this number, because basically what happens is whenever a box plot has outliers, we just cross them out, and whatever's left, that's going to be like the new 5-number summary. So the max is going to change, but the Q1 and median and Q3 will not. So you're looking for the box plot that if I go over here, right, so we have 13, 25, and 30. So you look over here. Is this 13, 25, 30? No, it's not. Look over here, 13, 25, 30. Yes, that's right. Well, that one also actually has 13, 25, 30. That's a problem. This one does not. So we already know that that one does not. And then remember that we had an outlier, right? And that was 59. So if you compare these two, the ones that where the middle was the same, the 59, that's a number very close to 60. So this is going to be this one right here, because this looks like the outlier is closer to 62 or something like that. So that's not 59. So I already know that this is going to be that. Okay, now to decide what to choose, it really just depends on outliers. Okay, so what you do is if you have outliers, then for the measure of center, you want to choose the median because it is resistant to outliers. If you have no outliers, so if it's yes, then we use median. If it's no, then we use the mean because it is actually not resistant, but you don't have outliers, so why worry about that? And mean can be shown to be slightly better than the median. Now, as far as the measures of spread, it also depends on whether you have outliers. If you do, then you use IQR. If you do not, then you use standard deviation. Same reasoning as for the center. So because we did have outliers, we got one outlier, we are going to use the median because it is resistant to outliers, and we're also going to use the IQR. Now, if you did not have outliers, imagine that you had nothing, and you would type D and E over here, then you would say it would be the mean because there are no outliers, or the standard deviation because there are no outliers. Okay, let's check our work here.